Okay, so what we have seen, actually we have seen our two variable such as ex and cons have long run equilibrium relationship, or our two variables are co-integrated, that we have seen. Okay, and when the variables are co-integrated, then we can run the error correction model. Error correction model only we can run when the variables are co-integrated. So as the variables such as ex and cons are co-integrated, we can run the error correction model as below. Model 1.2. So this one is our model 1.2 and this one is the error correction model. And here you see ex is the dependent variable. So in the error correction model, the variable must be stationary. The variable must be stationary. So what I have done, I have converted ex into first difference, right? Dex. Dex means first difference of x, first difference of ex. So this variable become first difference of ex, or this variable becomes stationary. And then B3, what is B3? B3 is the constant or intercept of the regression model, and B4 is the coefficient of variable decons. What does mean by decons? First difference of cons variable. That means cons variable has become stationary after first difference. And then another coefficient, which is B5. What is B5? B5 is the coefficient of ut minus 1. What does mean by u? U is ut minus 1, actually called residual. One period lag residual. That is ut minus 1. That means residual but one period lag. And what is the B3? B3 is the white noise error term. Okay, I am telling again. Here ex and cons are the first difference variables. B3 is the intercept. B4 is the short run coefficient. Make sure it is a short run coefficient, not long run. So B4 is the short run coefficient, not long run. And V is the white noise error term. But here, most important thing is this one. Most important thing is here, error correction term, this one. It corrects the disequilibrium. Okay. What is it? ut minus 1. ut minus 1 is the one period lag residual of model 1.1. I'm showing again. ut minus 1 is the one period lag residual of model 1.1. Okay, here what is model 1.1? So we can go up. Last time we saw it. It is model 1.1. What we have done here, we have estimated this model 1.1. Then we have taken the residual of this model. Then we have taken 1 period lag of the residual. And that one is actually this one, ut minus 1. 1 period lag of the residual of model 1.1. Okay. Ut minus 1 is also known as equilibrium error term of 1 period lag. Okay, this ut minus 1 is the error correction term that guides the variable that guides the variables such as ex and cons of the system to restore back to equilibrium. Okay. In other words, it corrects the disequilibrium. That means error correction term actually rectify the disequilibrium in the system model. That is her task. That is her action to correct the disequilibrium in the system. But the sign before B5 or the sign of error correction term should be negative after estimation. That means the sign, you see, B5 and the sign. This sign should be negative. The coefficient B5, meaning that this one, the coefficient B5 tells us at what rate it corrects the previous period disequilibrium of the system. That means the speed of the adjustment or the speed of the correction of the disequilibrium. That is the B5. B5 tells about the speed at which it corrects the previous period disequilibrium. And when B5 is significant and contains negative sign, it validates that there exists a long-run equilibrium relationship among variables stated in model 1.1. That means when the B5 is significant and when the B5 has a negative sign here, then it validates that there exists a long-run equilibrium associationship between Ex and cons, which are two variables. Okay. And what we have done, we have estimated this model 1.2, which is error correction model. We have estimated it. After estimating model 1.2, short run coefficient value B4 has been 0.41. That means the B4 has been 0.41, but it was not significant. Okay, and B5, what is B5? This one. And B5, the coefficient of error correction term has been 20.69%, meaning that the system corrects its previous period disequilibrium at a speed of 20.69% annually. So I'm telling again, the B5 after estimating has been 20.69%, meaning that system corrects its previous period disequilibrium at a speed of 20.69% annually. So that means speed of adjustment is 20.69% annually. Moreover, the sign of B5 has been negative and significant, indicating that there is a validity of a long-run equilibrium relationship between EX and cons. Okay, so meaning that B5 is significant and negative, and the value is 20.69%, at which it is correcting its disequilibrium. And here we have only used, in the whole error correction model, we have used only one independent variable, that is cons, but in reality you can use a number of independent variables according to the need of the model. Here I show only one independent variable, but in reality you can use more than one independent variables. And model 1.2 means this model. After estimating, the model 1.2 is not a spurious model because R square is less than Durbin-Watson statistics. So it means that our estimated model, that is 1.2, was not spurious or nonsense, because when a model becomes spurious when R square value is more than Durbin-Watson statistics. But here R square value is less than Durbin-Watson statistics. So model 1.2, which is error correction model, is not spurious. And this model I call it ECM model, error correction model, is true in case of single equation model. This one is a single equation model, so we call it ECM because it is a single equation model and one-way model, right? But what is VECM? VECM happens when there is a system of equations, meaning that there are many equations. Vector error correction model, VECM, That means that means there are a number of equation which can solve at a time. So that is VECM model. So that we can discuss later about VECM model.